Good evening. Welcome. I'm so excited to see such a big group this evening to talk a little bit about eclipses. My name is Shannon Baldioli. I am an educator at the National Air and Space Museum. My pronouns are she and her, and I'm joined by my amazing, brilliant colleague, Laura Blanton.
Hello. Wow, what an introduction. I don't want to introduce myself now. My name is Laura Blanton. My pronouns are she, her, and I am also an education specialist at the Air and Space Museum along with Shannon.
We're super excited for everyone to join us this evening. You can see our contact information on the presentation. I'll also point everyone toward that QR code that's on the presentation screen right now. That will take you to a PDF of this presentation in case you'd like to follow along with it this evening. Super happy to share the presentation with anyone who would like afterward, but I know I'm the kind of person that might want to pull it up on my screen and just reference it. So please feel free to use that QR code to do that as well. Before we get started, I just wanted to put our ground rules up there. I use these for all professional developments just to make sure everybody's on the same page. I won't read them to you because you're all amazing educators who can do that. But just want to make sure that tonight we're respecting each other's expertise and time. We're taking moments to pause, reflect, and learning from any moments of frustration or hardship, and giving everyone the benefit of the doubt. I don't think there are too many things that might cause frustration or hardship tonight. I sure hope not. So unless you're like not into neutral colored sweaters, or educators from Washington, D.C., I think we'll be good. But just wanted to set expectations for everyone so that we have an amazing experience this evening. So tonight, or this afternoon, I suppose, if you're on the other side of the country, we're going to talk a bit about eclipses. There's a huge eclipse coming up in just a few weeks at this point. I think we could probably count down the weeks at this point. On April 8th, the total solar eclipse is going to cross the United States for the last time in a couple of decades. So inspired by that, we wanted to kick off some eclipse content from the museum, talk to you about how, as a teacher, you could talk about eclipses with your students and how you might model them. We're going to show some physical and digital models. Laura's going to dig into an awesome tool called Stellarium and show you how that works. She's going to go through Stellarium kind of quickly tonight, so it's not necessarily going to be a tutorial, but we offer that as another professional development opportunity, and there's also lots and lots of tools on the web to get you started in Stellarium. So don't worry so much about following along tonight, more about kind of learning what Stellarium can do for you. And then I'll come back and talk about some of the resources that our astronomy education team and others at the museum have shared with the public to get ready for the eclipse. So to get us started tonight, we're going to do a little bit of minds-on because we're not all together and can't do hands-on, which is what we would prefer. But we're going to do a thinking routine called See, Think, Wonder. And thinking routines, if you're not familiar with them, were developed by Harvard's Project Zero and their Graduate School of Education. See, Think, Wonder is a simple thinking routine for examining objects or images. I love to use it to talk about museum objects. I also really like to use it to analyze a piece of art or an image. And tonight we're going to work on an image. You're going to take a look at an image. You're going to talk about or think about what you see, identify what you think about that, what you think about what you're looking at, and then what wonderings do you have or things, sort of blanks that you want to fill in. So we're going to take a look at an image. All right, so toss those C's and thinks into the chat if you'd like. I'm just going to talk through a couple of the ones that are in the chat. I think it should be thinner lines near the equator and thicker near the poles. Australia gets a lot of total eclipses, while the Americas get a lot more annular eclipses, which we'll talk about the definition of an annular eclipse later. Laura's going to model one for us, I think. Somebody said they see some travel opportunities. I love that. I'm like very secretly hoping to be in Iceland in 2026. It'll be my 10-year wedding anniversary, and I'm trying to figure out how I might make that happen. I love that. The Australians are lucky. I see a lot of people very jealous of Australia. Do remember though that they have the snakes and the jellyfish and like lots of other things that make it a little less desirable to be there. All right, how about wonderings? Do folks have wonderings we'll put in the chat? I just saw someone kind of kick us off with not sure what annular means. It makes you think of annual, and we'll talk about annular eclipses shortly. They are sort of a partial eclipse. The moon gets in the way of the sun, but not fully. Oh, how do we know these paths so far in the future? What a wonderful wondering and a great thing to talk about with students and a great and something we're going to dig into as well. Oh, what's seen at the end of the curves? What a fantastic wondering. That's actually something I haven't ever wondered about. Sort of what happens if you're kind of right there in Russia, kind of just at the edge of that big red line at the top. So these are incredible wonderings and a great this is a great activity that hopefully you might consider using with students. This is a great way to analyze images. Laura and I both came upon this image and really wanted to include it in some way because it's really fascinating and a little confusing when you first start looking at it. But then as you dig deeply into the data, it sort of becomes more obvious what it is. There are lots of interactive maps, and I'll share some examples of those a little bit later as well. But we're gonna move on. Again, these will be in the presentation, so you're welcome to use these later on. But before Laura gets started doing a little bit of digital modeling of eclipses, let's consider what an eclipse actually is. One of those astronomical phenomena that people, think they know, like how the seasons happen, and then sometimes you get to talking to folks and you're like, actually, I'm not sure how an eclipse happens. So, to put it in the simplest terms, an eclipse is when one object in space, such as a planet or moon, right, in our case, the moon, passes through the shadow of another object in space. So tonight we're going to touch on both solar and lunar eclipses, even though the big eclipse coming up that we're kind of looking forward to, and arguably the more breathtaking of the phenomena is a solar eclipse. So a lunar eclipse occurs when the Earth comes between the sun and the moon. So the sun and the moon are on either side of the Earth, and the moon is shaded by the Earth. And a lunar eclipse only occurs during a full moon because we need to see it in the sky. So the full moon is overtaken by the shadow of the Earth. And you get kind of that red glow on the front of the Earth. Anybody know why we get that red glow or on the moon? Sorry, not the Earth. Anyone know why that red glow happens on the surface of the moon when we see an eclipse? So the blues are absorbed by our atmosphere, leaving us with those red colors. So that's why sometimes lunar eclipse is called a blood moon because you get that kind of eerie red glow to it. And then a solar eclipse is occurs when the moon is kind of on the other side of in the other half of its cycle. So when the moon comes between the sun and the earth, and some of the sun's light is blocked by the moon, so we get that shadow. And we'll show you in just a little bit kind of what those look like, how you can model them physically with students. And I'm going to share some resources, some really great video clips that the museum has created that you can help your students see those from different perspectives. So, it wouldn't be professional development without a little pop quiz. So I've got a couple of poll questions. Please remember that this is a safe space. No one is grading you on this. I'm certainly not. So I'll pop a couple of questions up. Grab answers in the chat or grab answers in the poll. It should have just popped up. Question number one is why don't we have eclipses every month? So as you'll notice in the chat, orbits are at different angles. So the moon's orbit is tilted and it's much more difficult than just sort of thinking through those lunar phases, right? Like you would think maybe we should get eclipses twice a month, right? We have a full moon and a new moon all in the same month. So why don't we get a lunar eclipse and a solar eclipse every month? But the tilt of the moon makes it a little bit more difficult. They have to line up just right. Now I need to pop up quiz question number two. So the next two are true or false questions. We're going to do these quick. True or false? A solar eclipse always occurs about 2 weeks after a lunar eclipse. The correct answer is actually true. To go back to that tilt question, right? To get an eclipse, the moon has to be just right in line with the sun and the earth. And that tilt is correct on generally in the same month. So it's give or take, and it's not 100% of the time, but almost always a lunar eclipse and a solar eclipse follow each other within 2 weeks because of that lunar cycle. All right, I have one more question for you. This is a tricky one and one that I like best. True or false? One day there will be no more solar eclipses. It's absolutely true. And to those of you that said in the very distant future, you're exactly right. But right now, we're in this beautiful, very long period of our planet's story that is the rule of 400s. So the sun is about 400 times larger than the moon, and the distance between the sun and the moon is also about 400 times larger than the distance between the Earth and the sun. But actually, the moon is doing this to itself in about in several million years. We won't have any more solar eclipses because the way that the moon creates bulges on the Earth with the tides, the moon is slowly getting like bumped away from the Earth, very ever so slightly. Um, the moon gets bumped away from the Earth all the time. But that ever so slight bump is going to mean that eventually there's not going to be that perfect alignment. So instead of having a total solar eclipse, like some places will have on April 8th, you'll have what's called an annular eclipse, which is what happened in New Mexico and out west in October of last year. An annular eclipse is when the moon does pass directly in front of the sun, but it's not at the correct place to cover the entire sun. So you get kind of a ring effect around the outside. And we'll model that for you in just a few as well. Thanks for coming on that quiz adventure with me. So we've learned a few things with some fun facts. So we're going to jump into the modeling piece of this now. So Laura is going to spend about 20-25 minutes going through some models of on Stellarium of different eclipses. And then we're going to come back together, oh, closer to 30 minutes. Sorry about that. Then we're going to come back together and do some resource sharing, talk a little bit about eclipse safety, some of the resources we have at the museum, and other things you can do with it. So I'm going to toss it over to Laura.
So excited to talk to you guys about Stellarium. Before we dig into it, I have two questions I wanted to ask you all. First of all, give me a thumbs up reaction if you have ever used Stellarium. I'm watching the participants. I know you have, Shannon. Thank you for the thumbs up, though. I appreciate the participation. Okay, I am talking to kill some time because I'm not seeing any thumbs, which I'm going to give two thumbs up because that means I can share something that I love. No, but use, okay, amazing. So someone's looked at it, got to know. Maybe I've got some thumbs up that are
There
higher
were
up.
there were 12 thumbs in the chat at one point.
Oh, amazing. I love it. I got a thumbs down. Cool, cool, cool. I love Stellarium. I think it's super cool. And we actually use it for our virtual planetarium shows at the museum as well. Not in a couple of years. Amazing. Browsed yesterday, doing some prep work. That's awesome. I also used Stellarium earlier today to prep for this today. Hooray. So super cool tool that you can use. We use for virtual planetariums. It is free to use and it's open source. So something that you're able to use with your students. And you can choose your own adventure as far as how you choose to use Stellarium. Thanks, Shannon. You can click on the link that is in your chat. It's going to take you directly to the landing page where you can choose three different options. Option number one, it's web-based. You don't have to download anything. Students don't have to download anything, 10 out of 10. The second option is that you can download it as an app, which I have done on my computer. So as I talk through all of my controls, just keep in mind that the web-based version is slightly different than the app version. I also, I'm using Surface Pro right now, so it's Microsoft. So I have that version of the app. There is a different MacBook. I was going to say Apple app, MacBook app. And the controls are slightly different on that one. I found out in the middle of a planetarium show because I was giving on my personal computer versus my work computer. Big mistake. So that's slightly different. So as you hear me talking through the controls, just know if you're using a different version, those controls are going to look slightly different, Stellarium to Stellarium. But you're going to get a bunch of the same really cool stuff. So I'm going to go ahead and share my screen in just a second. What you're going to see is, drumroll please, Stellarium. Right now, you are looking at the sky from where I am in Washington, D.C., so not from where you are. I'll show you how you can change your location in just a second. One person asked in the chat a question I wanted to bring back to this conversation because we're talking about modeling. And I love having conversations with students about modeling data when we're talking about Stellarium, especially if it's middle school students. So the question is, how do we know what's in the future? How do we predict? Because with Stellarium, you'll notice down here, I have popped up my date and time toolbar. If you don't have it, you can click on this icon. It kind of looks like a clock. because time, duh. On this left-hand side, click on that. It's going to give you this toolbar. And then one of the things I love to do is show students, right now we're in year 2024, but I can travel through time and I can go to year 0 and look up at the sky. And I can also travel forward in time and see year 3000 if I want to do that. Wow, so cool. How do we know this? We know this because people have taken the time to create these models by analyzing patterns over time in order to create more accurate predictions of what we might see in the future. Talking about patterns is a big part of our planetarium shows as well. So that's why I like to bring that up at this specific point. Okay, so we've talked a little bit about models. We've talked a little bit about where we are in time. Let's go back in time. Buckle up. We're going to go back to 2024. Huge change. And I'm going to talk us through some of these different controls that you can see on my screen. So the first one is this compass, which is up at the top. So you can see my left-hand toolbar is gone when I go to the middle, but if I go over to the right, all those icons show up. Location window is one I want to point out for this session today. You can change your location. I'm going to go to different places as we talk about different eclipses, but just wanted to point out where that was right off the bat. I'm also going to change time, so I'm going to keep this time toolbar right here as well. You'll also notice a couple of other helpful things. So we've got our sky and viewing options, our search window, and we can add on different labels if we want to. Like Shannon mentioned, you can use this for so many different things. You can talk about different constellations. They've got constellation art that can show up in the sky as well. So that's really cool to talk about. And there is linked information about some of those constellations too. So that's a super, super quick summary of what Stellarium can do. I think it's super fun. I'm going to zoom out just a little bit. You can see our ecliptic, which I normally have set. You can see planets. We always talk about planet hunting as well when we wind up doing planetarium shows. And you can look at fun different solar system objects. So right now I'm going through February. So you can see that the sky is changing slightly, right? And we have our moon up in the sky. So we always use Stellarium to talk about our moon phases as well. So right now I've selected my moon. You're going to see me centering on a lot of objects because I don't want to lose them. And as we're traveling through time, those solar system objects can move. So I'll center. Yes.
Quick question for you. I don't know if you know the answer to this, and we might need to just scoot on. But do you know on the desktop version how you get those icons to pop up? We've had a couple of people asking.
So, as far as icons, like what can you clarify a little bit what that means? Do I mean like the labels or the ecliptic line? So I'll go to settings really quickly so we can
The
take a
ones on
look
the
at
left. So when you go over to the left and see those on the
these.
desktop version, do you just kind of hover over to the left?
Yeah, so for the desktop version, the location of the different icons changes. So I would suggest searching around for a little bit. So most of them are going to be like there are a lot that are going to be nested down in the bottom that you'll need to use, but the setup is different for the web-based app. I can pull it up at the end if people still have questions so we can talk through some of that. But I will also say the web-based app is really great, especially for some general information. You can do a lot more in the app versions, which makes sense, right? But that is one like larger difference between the two platforms. I know that that's not super helpful, but
No, it's
uh,
all good. And I don't think we can troubleshoot tonight, so we may have to just kind of take a look into it. But I didn't know if you had that one. So we can just soldier on and find those answers later.
yeah. I think it's easier to kind of like look and I'll talk about it at the same time. So I do want to talk about the moon. So we're gonna look back at the moon really quickly. I'm glad that you guys are searching along in your web app versions though. So right now we're centered on the moon. And then I'm gonna focus in on the moon. So buckle in again, we're gonna fly out to the moon. And one of the things that we always like to do is talk about our moon phases and travel through time so we can see what the moon looks like during different seasons, right? So just going through an entire month. I think I lost my moon. So this is what happens sometimes. It just winds up getting a little lost and then we found it again. I also did not turn off my ground. So if you're doing moon phases, you also do need to turn off your ground in order to do that. You saw it went black. And that's what happened during that time. So, what we're going to do is we are going to travel through time and through different locations to see different lunar and solar eclipses. So, I'm going to start off with our penumbral lunar eclipse. So, this one is very, very easy to miss. I did just want to show it because it is a type of lunar eclipse that can be experienced. Shannon, do you mind sharing your screen and showing the infographic of the shadow? Thank you. So this I find really helpful in talking and thinking about lunar eclipses because what you see is based upon the location of the moon. So what we see is our sun, earth, moon system. When the moon is in earth shadow or umbra, you're going to get your lunar eclipse. So that's the setup that we have right now. But what you can see is the earth shadow is a little bit bigger than that, right? So you've got the outside shadow, which my pointer is in right now. So you can see kind of like the two triangles that are around the main part of Earth's shadow or umbra is the penumbra, right? So when there's a penumbral lunar eclipse, basically what that means is that the moon is in one of these outer parts of Earth's shadow. So we're going to go back to Stellarium really quickly so we can see what this looks like. And see, we've got lots of chats. Amazing. I'm going to share so we can take a look at this. And we are going to travel to March 25th. My location is still set in Washington, D.C. Let me make sure that that pops up over here so you can change your window if you need to. I'm set in Washington, D.C., like I said, because that's where I am. And then I'm going to change our date and time. My Stellarium is lagging just a little bit. So if you see it lagging, it's because it's lagging for me as well. Sometimes it gets a little spicy. Okay, so March 25th, 2024. So we're in 2024. And then I'm going to start us off at around 1 a.m. I always try to look at the time beforehand because sometimes you can ruin the surprise a little bit, and no one likes a ruined surprise, least of all me, because I like to be dramatic about it. So we're going to go to March 25th. Shannon's laughing at me because she knows it's true. And I'm going to search for our moon. I also love this search bar because if I'm working with students, I don't have to search around frantically for whatever it is that I'm looking for. So you can still see that the ecliptic line is on there. I always have it set for my planetarium shows because it's going to be the line that our solar system objects are going to travel along. So I'm going to take it off because we don't need it right now. So I'll go to my markings, ecliptic. Should have done this beforehand. You're seeing the ugly behind the scenes. I'm so sorry. So we've turned off our ecliptic. You can take a close look at the moon. I've got centered on the moon. And then I'm going to zoom in a little bit more. So I am going to tell you that this one is hard to see. Once again, I know I've said that one time, but just repeating it, I'm going to have us travel through time. And I want you to write in the chat whether or not you actually observe any changes. So what I'm going to do to move us forward through time, you can see that I've got my date and time set. I have us starting at 1 a.m. Past everyone's bedtime. And then I pause time. So I'm going to start time again. And actually what I've been doing for watching eclipses is fast forwarding time because otherwise we would be sitting here and watching time tick by until 5:30 a.m., which no one has time for. So we're going to fast forward 3 times. Time is flying. And you're just watching really closely, looking at the moon. Once again, as Shannon said, our lunar eclipses are going to happen during that full moon phase. So our 3 examples that we're going to be looking at are going to appear like full moons. Okay, it's 5:30 in the morning. Time to wake up. Also, did anyone see anything happen? Let me know in the chat. Oh, okay. Well, we have someone who has better vision than me, Shannon, because I did not see it when I first looked at this. Okay, we have several people with better vision than me. A couple of people. Yes, you've got a slight shadow over the moon. Shadows come and go. Awesome. Very subtle. It is very subtle. And I was talking a lot during that time, partially as a distraction, maybe to myself, maybe for other people, maybe for Shannon. So what we're going to do for people who are like me, who maybe didn't see it the first time around because they got distracted, people who did, amazing. It just looks slightly different between different times. So we're going to go back to 1 a.m. Actually, 12:53 is what I wrote in my, oh my goodness, I'm so embarrassed. You can see the ground. Okay, so let's take the ground away. So we're going to go to midnight. And then we're on our correct day. So we're looking at the moon before that penumbral lunar eclipse occurs. And then the max stage is going to be at 3:12 a.m. So I'll change my time. So we're looking closely. And then you can see that it's significantly darker at this point, right? Because it is in Earth's penumbra at that point in time. So this date is March 25th, 2024. We are going to see the solar eclipse that is paired with this one, which is why I wanted to show this penumbral lunar eclipse. That's going to be our closeout for the very end, which will be very exciting. A hint is that it is, someone probably is already, most of you have probably figured this out. It's the April 8th solar eclipse. Ta-da! Okay, so what we're going to look at next is a partial lunar eclipse. Once again, we are in DC because that's where I started most of my eclipse viewings. What the partial lunar eclipse is going to be is that the moon is passing through Earth's umbra or shadow. Remember that infographic I showed you? It was kind of, ooh, my finger blurred. It was kind of that like cone shape shadow that we observed on that infographic. So we have to watch really closely for this. And then you will see this again when we look at our total lunar eclipse as well. Okay, so our partial lunar eclipse that we are going to observe is on September 17th, 2024. So we're in the same year. Go to September 17th. So we've got our full moon stage, and we're going to start at 10 p.m. or 22. We'll start here. And then once again, we're going to press fast forward, right? Like I didn't freeze time at this point, but it's helpful to fast forward a little bit. And I'm going to double check. We're good on dates. So I want you to watch the top part of the moon to observe changes. So you'll start noticing a change. We're watching very closely. You can see it now. It looks kind of like someone is taking a bite out of the moon, which isn't true, but that's what it looks like. So we can see that shadow growing and growing on the top part of the moon. We're observing a partial lunar eclipse. And then it will recede and it ends around 11:20. So this is helpful to see because we're moving into a total lunar eclipse. So you can see the difference between those two perspectives. I'm going to go ahead and freeze our time once again because we've been able to observe this. Hooray. And we are going to travel forward in time to March 14th, 2025. And we are going to stay in Washington, D.C. for this as well. So didn't need to pull that up. Change our year first. So we're 2025, go to March 14th. And then we're going to start at 1 a.m. Oh no, I'm spoiling some of the surprise. Whew, thank goodness. And then I'm going to press fast forward for us so we can observe this. So we talked a little bit about our lunar eclipses with Shannon a little bit earlier. So we talked a little bit about the color change that we're going to observe and why that occurs, right? We're seeing that the Earth is absorbing those blue rays, and then we're seeing that the red light goes through, right? So our moon is going to appear a reddish color. We're going to start observing a partial eclipse in just a moment. I'll press fast forward again. This kind of helps with our time. And you can see less of the moon in the bottom left corner. So that shadow starts to overtake the moon. Um, and then we're going to start observing a change in color in just a second as the moon has more and more shadow on the near side. I promise it's going to start changing color any minute now, any minute, very, very soon. And it's very dark. You can start to see that it's changing. So we've got our total lunar eclipse, sorry. And then it'll start to recede as well. So it's nice to observe using stellarium because you can see right these different eclipses. I kept our location the same for our lunar eclipses, but I'm going to change locations when we're looking at our solar eclipses. So you also can see things from different perspectives. You can change the locations and the dates based upon where you are. So it applies more directly to students' lives versus they don't want to see things from the Washington, D.C. perspective, unless you're from D.C. And I know we have some D.C. people who are here, so hooray. So you can change your location. You can find your eclipse dates and plug those in pretty easily, or you can have students research them and show them using stellarium as well. So right now we are practically done observing this total lunar eclipse. We're going to go ahead and rotate and move into our solar eclipses. What we're going to do first is we're going to talk about our annular solar eclipses. Someone asked a little bit earlier what the word annular meant. It means ring shaped. And we're going to see why very soon. So I'm going to go ahead and pause time. And we are actually going to travel through locations. We're going to go to Albuquerque, New Mexico for our annular solar eclipse. And we're going to change our date as well. So we're going to go back in time to 2023. And we're going to go to October 14th. And we're going to start at 7:30 a.m. Oh, that's a 4. That's not a 7. Oh my goodness. And we're going to change our location. So we're going to go to Albuquerque. There we go. All right. So I've got my year, got my date. The one thing that I need to do is uncenter on the moon, and then I'm going to back up a little bit so we can see everything a bit better. And then I'm going to make sure that my ground is on. There we are. All right. So I'm going to zoom back in just a little bit so we can see a little bit better. As you can see, it is going to look kind of pixely regardless of how zoomed in or how zoomed out you are. I want to make sure that we're close enough to observe this a little bit more closely. And then I'm going to also center in on my sun so we don't lose it. Once again, I always center in on whatever object we're looking closely at if we're moving through time, because our objects are going to move and I would prefer not to lose any of them. Okay, so we're starting at 7:30. We're going to observe an annular solar eclipse. This occurs when the moon is closer to its maximum distance from the Earth in its orbit. And we're going to observe, right, the word annular means ring-shaped. So we're going to observe this to figure out why it's called that. So I'm going to go ahead and fast forward through time just a little bit. I'm going to go to, we're at 2 times right now, and I'll go to 3 times because that makes things a little bit easier. The moon appears, right? That's what's coming close to the sun. And then, dun, 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 right? It's going to move over, and I didn't stop it at the perfect time. I'm sorry. So we'll back it up just a little bit. And what you're going to observe, kind of why it's called, let's back up. That's not doing what I expected it to do. Our annular solar eclipse. Basically, what happens is the moon is not going to fully cover the sun. And so you're going to get a ring shape of the sun, right, around the moon. So that's why it's called annular. Sometimes it's called a ring of fire, which I think is really cool. Go back there. And so you can stop it at a better time than I stopped it. I want to move forward for the sake of time. Instead of having you watch me struggle finding the exact second, where you can see the ring of fire effect, you can get the sense of how you can find that and see that using stellarium. Okay, so for comparison, you can go to Washington, D.C. Or another place to observe a partial annular solar eclipse as well. So I can go to Washington, I can go to the same time once again. And basically, you're going to see something very similar, but you're not going to get that full ring of fire effect like we got in Albuquerque. So I'll go back in time and then I'll go ahead and fast forward us. I'll do 2 times so it moves a little bit more slowly. And we'll watch the moon kind of go around the sun instead of go through and give us the ring of fire effect too. And after this, we're going to move into our total solar eclipses. I think we're running pretty good on time. And then if I have another second, I'm trying to speed up how fast I'm talking, Shannon, to make sure we get through everything. I'll move this a little bit faster, and that'll give us a little bit of time potentially for questions too. Okay, so we're watching the moon move. It's moving closer and closer to the sun. And like I said, it's going to move kind of down and around instead of going directly through the sun. So we're still going to see a good amount, but it's really cool to observe. And I think that stellarium gives us a really great perspective on how this looks different from different locations, right? Like we just looked at the same thing from Albuquerque, but watching from DC, it's going to look slightly different. Also, you don't have to have eclipse glasses on while you're watching this. So it's very safe for our eyes as well, which is wonderful. Seems like it's moving not as quickly. Probably super, super sped it up last time. So we'll speed it up. It'll go around down the bottom. So it doesn't cover as much of the sun up as it did from the Albuquerque perspective, so from that path of annularity. But we did get a really cool view of the moon moving over the sun. And then the sun is going to set. Okay, so we're going to move into our total solar eclipses, which I'm sure is why everyone is here today. I'm going to show us 2 different perspectives. First, the perspective from Washington, D.C., which is why we moved here in the first place. And then we're going to go to the path of totality to see what that looks like as well. So we're going to go to April 8th, 2024. So we'll go forward a year, and then we'll go to April, and then we'll go to the 8th. And then we're going to start at 1:40 in the afternoon. Military time throws me off. Okay, and then we are going to observe what this looks like as a partial, and then while we're on the path of totality as well. So we're going to go ahead and press, we're on play, we're going to fast forward. You can already see the moon. So we've started around 11:30. Oh, no, we did not start 11:30. Oh, I was going to ruin the surprise. I'm so sorry. So change time a little bit to make sure we can see all of this. Because why are you here to not get the aha moment? And then we'll zoom in, and then we'll center, and then we'll zoom in. Ooh, didn't miss a thing. Okay, so we're going to move forward until about 2:30. So we fast forward through time. You can kind of see the moon pretty faintly off to the right-hand side. We'll continue to observe it moving forward. I can speed up a little bit too. I just don't want to ruin the fun. So you can see that the moon is crossing over the sun. It gets dark, but you can see from that how the moon doesn't totally cover the sun, right? Or block out the sun from this perspective. So we've got a partial solar eclipse versus, and I'll pause time because this is going to move so quickly. We're going to travel to Dallas, Texas, which will be in the path of totality for our next perspective. Going all over the place. Let us know if you are going to be in the path of totality as well. If you know if you're going to be in the path of totality. So we're traveling to Dallas for this perspective, but maybe you don't have to travel anywhere, which I'm super jealous of. And I know Shannon is as well. We're going to stick to the same time. So I'm going to start us once again at 11:30 instead of 1:30. I'm not going to ruin it this time, I promise. We're on the correct day, which is April 8th, and we're already moving forward in time, but I'm going to speed us up just a little bit. I'm going to slow it down so that it's not quite as fast as it has been for some of our other sessions. This one's my favorite one out of all the eclipses to observe, especially using stellarium. I think it does model it fairly well, and you see the difference between the partial and the total solar eclipses pretty distinctly. We're just moving really slowly so that we can make sure to see everything. I'll move us just a little bit faster. I don't think it'll ruin it. Sometimes it moves so fast, it kind of spoils the fun of actually observing it. So it's nice to be able to speed it up because you don't have all day to sit and watch the entire eclipse or all the eclipses that we've observed. But it's nice to be able to slow it down, but not go too slow or too fast. So we can see the Earth. Oh my goodness, we're on Earth. We can see the sun. We can also see the moon, and the moon is moving closer to the sun. So it's starting to get to the maximum point of the eclipse. So I would say like I started this at 11:30 a.m. And I move it forward in time through 2:30 p.m. So right now we're just after 1 o'clock. I think it's nice to start it a little bit earlier than when the eclipse actually occurs, so you can see the full motion versus just seeing the actual thing. So we are starting to see the eclipse occur, and then you can see that the moon totally eclipses the sun. So we get this like change in perspective, which is cool to see. And then we can see that the moon is moving away from the sun now too. So all of our solar eclipses occur during our new moon phase. So you can also see that as you're going through these different solar eclipses too. So we just went through a lot using stellarium. I know it was a lot of me talking at you using a new tool. So hopefully it wasn't too confusing or too much. I'm going to take a look at the chat. And I'm happy to answer any additional questions that there might be about stellarium too. But Shannon, I know you have a lot to share about additional resources. There's another super cool modeling tool within those resources. One of the things we like about stellarium is that you can see so many different eclipses from different locations. It's not just like this one solar eclipse that's going to happen in April. So even one thing that you could do is you could use the graph that we showed at the beginning that Shannon led the See Think Wonder around. So you can use that graph. Students can pick an eclipse that they're interested in observing, travel to one of the locations that they think they might be in the path of totality or annularity for, and then observe the eclipse that they picked from that location. So that could be a cool way to use these two different tools in tandem too. And with that, Shannon, I will stop talking and kick it back off to you.
So I saw a couple questions in the chat that oh, I saw someone grab one. How many seconds will the moon totally cover the sun? It depends on where you are. I think at the very, very center of the line of totality, it's about 4 minutes. Where I'll be, which is kind of on the edge of totality, in my mom's backyard in the Youngstown, Ohio area, I think we get about 2 minutes of totality. So it just depends on how close you are to that. And then, yes, Andrea, I'm sorry if I pronounced it wrong. Um, you can, so once you get to totality, if you stop stellarium right on that moment, I believe it does show the starry sky behind it. So you should be able to see what you'd be able to see in the sky at that moment. If we were to use that. We're definitely going to be ready to move. Clouds are going to ruin the view. Northeast Ohio is not necessarily the best place cloud wise in April, but we're going to try it. I'm hoping for good weather for everybody. So I want to talk just a couple minutes about modeling, a couple of different modeling activities. If you don't use an amazing tool like Stellarium, which again, Laura and I are here as a resource to talk to you about that after the fact, please feel free to follow up with us. We do offer a full hour professional development on this. So if like other folks in your school are interested in it, or if enough people are generally interested, we could potentially schedule a public PD on it. But we do a deeper dive in this Stellarium if you have other questions. So just a couple of other models, especially if you have younger students, if you've got late elementary, middle school students, this is kind of a classic model of moon phases that you can start off talking about eclipses. So you take a poster board and some ping pong balls and paint each of the ping pong balls half black and half white. And then you put the sun down at one end, and then the earth is your head. So you pop your head through there. It looks hilarious. If you do it as a teacher, the kids get a big kick out of it. And then you move your head around and you can sort of start to see the phases of the moon. It's a great way to get students moving and thinking about the phases of the moon. You can also always use the sort of styrofoam ball on the end of a pencil and a light source from the side to model the moon phases as you move around. But this poster board is a little bit easier for especially our younger learners or folks with some accessibility needs because you don't have to kind of line it up yourself and get it quite right. It's like a fun thing to kind of spin around in a circle. And then if when we're talking about that tilt, right? So like you can answer the question with your students, why don't we have eclipses twice a month then? If you move to this hula hoop model with a light source and a globe, although now that I'm looking at this globe, I think this is a Mars globe. But the globe, if you put that ping pong ball on, you can really use that tilt to show what it looks like. And it really helps students with perspective too on just how big that shadow is. Remember, we were looking back at that map earlier, and people were wondering sort of why there were slices of the world missing, or why it's such a narrow sliver. Because the moon, that shadow of the moon, when you're in totality, right, it seems to totally cover the sun, but it's a shadow that's moving, that's very small in relation to the surface of the Earth moving across the Earth. So that's a great way to model this as well. And there are some details on our website, which I'll show you in just a moment, about how to set these up if you want. I'm going to show you a really quick video of another modeling activity, which is a great modeling activity for especially older students, where you can actually model this outside. So you can see that that video is kind of set you up to show you the actual places that you can put the items to create an eclipse when you're outside. This is a great challenge for students, a great cross-curricular connection if you're a science teacher and can connect with your math teacher or vice versa to talk about this. Have the students figure out what that ratio is to create the eclipse. And you've got a great sort of quick cross-curricular modeling activity that gets the students inside and gets them thinking about it. So I want to dive into a couple of things specific to the eclipse. We have about 10 minutes left, so we're doing great. I'm going to go really quickly over eclipse safety because it's important to us that folks know about the safety aspects of this. And then I want to take you on a really quick zip through our webpage to show you some resources. So when we're talking about this solar eclipse, April 8th, please remember that looking at the sun is dangerous without any kind of filter. So you need to wear some sort of approved eye protection if you're looking at the sun. The only time that it is safe to look at the sun without some kind of eye protection is during the minutes of totality. Only during those minutes, if you are in the path of totality, is it safe for you to remove eye protection. So you always want to wear, you can use eclipse glasses found through a reputable company. We have some resources on our website about how you find those. You could use welding goggles in shade 14 green. If you were to be looking through a telescope, you need to be looking through a telescope that somebody that's an expert with telescopes, solar telescopes, is set up with an appropriate solar filter. Never just look through a regular telescope at the sun. Um, or you can view indirectly with a pinhole viewer of some kind. You can take a colander outside and take a look at it, and you'll see the sort of shape of the sun get gradually and gradually more crescent shaped and then disappear if you're in the path of totality. If you look indirectly with a pinhole viewer. But we just want to make sure that everybody knows that you need to have the some appropriate eye protection to observe the happenings of an eclipse, unless, like Laura said, you're doing that observing on stellarium, in which case no glasses needed. Local libraries definitely have resources. You may look at museums in your area, science museums in your area. And Erin, I do have suggestions for reputable companies. I'm happy to show you that on our website. You just want to make sure that they've got the correct amount of eye protection. So these resources will be available to you when you have the presentation here. I'm going to show you our website in a second, but NASA, NSTA, the Exploratorium, and the Association of Science and Technology Centers all have amazing resources. NASA has a great landing page with maps and simulations of the eclipse. NSTA and the ASTC and the Exploratorium have great resources for teachers if you're looking for activities. And obviously Air and Space does as well. But these are some resources that I wanted to highlight so folks know that they can go there. So I'm going to quickly show you our landing page for all things eclipse. Our absolutely spectacular astronomy team, Shauna and Marielle, Shauna, whose gorgeous hands you saw in that demonstration with the yardstick, have worked with our scholars and scientists at the museum to put this together, as well as other educators. This video I can't recommend more highly if you want to look at sort of the way that solar and lunar eclipses look from different perspectives. They show you an animation of the perspective from space. We talked about that changing color of the moon during a lunar eclipse, and it kind of puts you on the moon and shows you from the moon's perspective. This is a great little video that you can use chunks of to talk about with your students. Here's the path on April 8th, and you can view that map much closer. And then here's that safety information that I was talking about. So the American Astronomical Society, AAS, which is in the middle there, has a list of reputable companies that make eclipse glasses. Strongly recommend taking a look and making sure that the glasses that you might purchase are approved glasses. And you can also find a list of local libraries on this website that's growing. NASA has guidelines for your glasses. If you were lucky enough to get glasses in 2017, and you kept them, you can still use them as long as they're not torn or worn in them. And then here's some other ways to view the eclipses. To view the solar eclipse, there's some 5 fun ways there. I got some FAQs. Why can't you look directly at eclipse? We've got some really great stories. An eclipse chaser talks about their experiences, kind of the experiences of appreciating a partial eclipse. In Washington, D.C. in 2017, I was at the Udvar Hazy Center giving out glasses, so we appreciated a partial eclipse. I'm really excited for totality, but it was an amazing experience to stand with people looking up at the sky all together and just marveling in the phenomenon. So appreciating a partial eclipse is also possible. And then there's lots of activities down here. So anywhere activities, we've got art, multi-sensory activities, some demonstrations on scale, some early childhood. You'll notice a couple of these images down here. And then as programs start popping up, if you're in the Washington, D.C. area, we'll be talking about eclipses over the next couple of months. And then there's some also video resources that you can look at here. And then finally, it's like sort of a shameless plug, but it's cool. NASM has a solar eclipse collection that you can purchase some merch, which is really fun. Staff got some access to it before the holidays, and my family was excited to get some eclipse merch. So that's a pretty neat one too. So I wanted to finish out our time together again by saying thanks to everyone for joining us this evening and sharing some cross-disciplinary ideas. One thing that we really strive for is making sure that all of disciplines can take part in this. So art is a great way to explore eclipses. You could do pinhole art. If you see here, somebody just took a hole puncher and made the Smithsonian holes. We did some letter outlines with kids, and you could do like the letter of your first name and then project it. You could also study eclipse-inspired art. So this is Washington, D.C.'s own Alma Thomas, a piece of her artwork called Eclipse. It's a great way to use some of those thinking routines. to think through, what the artist was expressing here in her piece called Eclipse. If you've got the little littles exploring light and shadows, you can use puppets and you can use a light source and talk simply about shadows and what they might see. That yardstick demo, as I mentioned earlier, could be a discussion on ratios. And then there are a couple of amazing books that I wanted to highlight. I have a 5-year-old at home, and we have both of these books and have been really enjoying them. So, Eclipse by Andy Rash talks a little bit about the experience of a father and son viewing the eclipse together. And then this book, A Few Beautiful Minutes, is a really cool multisensory description of the eclipse. Talks about sort of experiencing the moments of totality with all of your senses. And it's a really exciting way to kind of model it for little ones, especially if you're in totality. It's really strange for the sky to go dark in the middle of the day. I noticed someone in the chat earlier was talking about their students kind of freaking out that the streetlights came on. So this is a great way if you want to kind of prep your students or your own kids for what the experience might be like. It's beautifully written and illustrated, but it's also a really great description there. Again, we so appreciate your time spent with us today, but that does it for us tonight. We really appreciate you being with us this evening.